Hello everyone and welcome. In this beginner-friendly Blender tutorial we will create a little robot character from scratch while learning the essential tools step by step. We will start with the basics, setting up reference images and learning simple viewport navigation. Then we will move into modeling with key techniques like extrusion, loop cuts, proportional editing, modifiers and more. As we build our character, I will explain essential modeling techniques like selection methods, beveling, transform orientation, and snapping, along with shading options and how to organize your project. Finally, we will add materials and setting up basic lighting and create a simple final render. This tutorial is perfect for absolute beginners. I will explain each concept clearly as we build together. Let's get started. Here you can see all the keys I am using. If I press shift or left mouse button, you can see it. We don't need the default light and camera, so I'm holding shift and left clicking to select multiple objects. Then I'm pressing M to move them to a new collection, and you can name it whatever you want. A collection is a folder in Blender where you group objects to keep your scene organized. Then you can hide all the objects inside this collection with this eye icon. We don't need this cube either, so let's hide it. Now we want to add the reference image. To do that, open the Add menu or just press Shift A, then go to Image and choose Reference. After that, just pick the image you want to use. You can download this reference image completely free from the video description. And if you would like, you can leave a small tip on ArtStation to support my work. When you edit, Blender aligns its rotation to match your current view. You see the rotation values are not zero. In Blender you can select multiple fields and set them at the same time, or you can use Alt-R to clear the rotation. Press R to rotate. The angle appears here in degrees. Press X to constrain the rotation along the X-axis. Then type 90 and press Enter to confirm. To change the angle view, press and hold the middle mouse button and move your mouse. For orthographic view, press and hold the tilde key. Then choose the view you want to use. Scroll the middle mouse wheel to zoom in and zoom out. Hold Shift and drag with the middle mouse button to pan the view. I want to move the reference image so that the robot is on the ground. I press G to grab, then Z to lock the movement to the Z-axis. While moving an object, hold Shift to move it more slowly for finer control. We want the center line to be aligned with the Z-axis. So I'm pressing G to grab, then X to constrain the movement to the X-axis. As you can see, it's hard to tell if it's aligned correctly, so we will make the image transparent. I will turn on opacity in the Data tab, and from there you can adjust the value to your preference. If I switch to the right side view, you see there is no reference image. I will duplicate this one and use it for the right side too. For duplicate, you can press Shift D and then press right click or escape to cancel movement. And then you can rotate pressing R, then Z to lock to the Z axis and type 90. We need to adjust the right side image too. I want to match the Z axis to the center of the shoulder. So I'm pressing G, then Y and holding Shift to move it slowly. If we look around, you will see that X location for the right side image is not correct. Go to Object tab, set X location to 0 and press enter to confirm. When you select an object in the outliner, it's automatically selected in the 3D viewport too. The same thing happens in reverse. If you select an object in the 3D viewport, you will see it gets highlighted in the outliner as well. You can use either method to find the object in the 3D viewport or the outliner. Next, let's give the reference images proper names and create a collection for them. Here you can see the current view. To rename objects, you can double-click or press F2 in the outliner. First, select the image in the 3D viewport so we can find it in the outliner. Rename it front since we are in the front view. Then switch to the right view and repeat the steps. But this time rename the object side because it's visible from both left and right views. Hold Ctrl to select multiple objects in the outliner. Then hover over the 3D viewport. Press M to create a new collection and name it References. I think we are ready to start modeling our robot. Let's begin with the head. I will add cube by pressing Shift A. When you add a new object, it always places it at the position of the 3D cursor. 3D cursor is this little red and white circle. Think of it as a marker you can place anywhere in your scene. It's often used for adding new objects, snapping or setting a pivot point. You can move it by holding Shift and right-clicking. With Shift C, it snaps back to the center. Looks like X-ray is on. It just makes objects transparent, which is useful here to see the reference image behind. You can toggle it on or off from this button, or press Alt-Z. Then I will grab the cube using G. Press Z to move it along the Z-axis, and position it roughly at the center of the head. From here you can choose the interaction mode. Until now we have been in object mode. This is where you move or organize entire objects. If we switch to edit mode, we can start changing the shape of the object. In Blender, many objects like cubes, sphere and characters are made of something called a mesh. A mesh is made of vertices, edges and faces. If you want to select vertices, you have to use vertex selection mode. Now I can select vertices. These points are vertices. Vertices are starting points that build the shape. Edges are lines connected to vertices. If I switch to edge selection mode, I can select edges. Faces are flat areas between edges that create the surface of the mesh. If I switch to face select mode, I can select faces. In edit mode, press 1 for vertex select, 2 for edge select, and 3 for face select. I'm pressing 1, 2, 3, you see it changed the selection mode. And remember, all the shortcuts we talked about before work only when your mouse is inside the 3D viewport. That means your mouse must be here, not over there. On the left side of 3D viewport, you have got the toolbar. It's where you will find tools like box select, move, rotate and scale. We are not going to use it much since we are relying on shortcuts. But if you ever forget one, just hover over a tool. It will show you the key. Right now the select box tool is active. If you click and drag, you will select everything inside that box. Then I will switch to front view and vertex select mode. I will select this vertex and you will see the vertex behind it also selected. That's because X-ray is on. If I turn it off and select this vertex again, only the front one gets selected. Let's move on and refine the head a bit more. If I start moving the vertices, you will see they are not enough to shape the head. Let's add a loop cut here. It just adds more edges and vertices, so we can shape things better. I will press Ctrl R to bring it up. You can also find a button for it here in toolbar, but I will stick with the shortcut. Then I will left click to place it. After that you can slide it to adjust the position, and either left click again to confirm or right click to snap it to the center. As we used G and R to move and rotate in object mode, we can use them the same way in edit mode. G for grab and R to rotate. And similarly, we can use S to scale. For example, if I press S, I can scale, and then if I press Z, it scales only Z-axis. Now we will start aligning some of the vertices around the head. We will use reference image as a guide to match the overall shape. We are missing some geometry here, so I will add another loop cut to give us more control over the shape. I'm trying to make the edges about the same length. I'm just aligning the vertices on one side of the head for now, because we will use the mirror modifier to automatically copy everything to the other side. That means we don't need those vertices, so I am deleting them now. To delete vertices, press X, then choose vertices from the menu. To add the mirror modifier, go to Modifiers tab in the Properties editor. Click Add Modifier. Then either start typing mirror to filter the list, or find it under the Generate category. And now you can see that one side is mirrored. Any changes I made on the left are automatically applied to the right. Mirror modifier is using the x-axis, so it mirrors the mesh from the left to right or right to left. That works here because the model is symmetrical across the x-axis. Right now the center vertices can move freely. If I move it to the right, you see it also gets copied to the left. But when I turn on clipping, it keeps middle vertices stuck together. Next, we will add a Subdivision Surface modifier, the same way we added the mirror modifier. This one smooths out the model by adding more geometry, so it looks more rounded. Each modifier has the screen icon next to its name. It turns the effect on or off in the 3D viewport. It's a great way to check what the modifier does. Right now X-ray is on, but if I turn it off, you will see the effect more clearly when I toggle it. Until now we have been working in solid view. That's the default shading mode where you see the surface of the model. Let's switch to wireframe mode for a moment. This mode shows just the edges, so you can clearly see all the geometry including what the modifier is adding. At the moment Blender is hiding some of the extra wires to keep things clean. That's thanks to this option called Optimal Display, which is enabled by default. If I turn it off, you will see all the extra edges the modifier is generating. We need to select this edge loop because we are going to delete it. The Subdivision Surface modifier is already adding enough geometry. Reducing the edges makes it easier to align the shape to the reference image. To deselect everything, you can press Alt-A, and to select edge loop, hold Alt and click one of the edges. Then I am pressing X and choosing Dissolve Edges to remove it without breaking the mesh. This keeps surrounding faces intact, unlike deleting edges, which can leave gap. After that, we need to realign the object surface to the reference image, because the Subdivision Surface modifier smooths and slightly shrinks the entire object. I'm switching to solid mode and turning on X-ray so I can select the back vertices too. I'm selecting the vertices and pressing G to move them. Keep in mind, when you are in front view, you are only affecting the X and Z axis. The Y axis is pointing straight at you, so you can't really move vertices in that direction. Before I start moving vertices, I want to add some loop cuts, so I have roughly the same size faces. Remember, you can press Ctrl R to add a new loop cut. I'll add one here, and another one here. Now I will start moving the vertices, and again you can see all the keys I'm using right here. Here I will switch to face selection mode, holding Shift to select multiple faces and scale them along the y-axis. I think the head is fine for now. Next we will model the torso. Remember, we can use Shift A to add another cube. But since we are in the edit mode, that will edit as a part of the same object. So it's better to switch object mode and then use Shift A to add a new cube. Now we have got two cubes, Cube 1 and Cube 2. Let's rename them to keep things organized. When object is selected, Blender shows this little orange dot. That's the object's origin. It's the reference point Blender uses for positioning, rotation, and scaling. Think of it like pivot. The object moves and spins around it. For example, if I select the torso and change its location coordinates, I'm actually changing the position of its origin point, and the whole object follows it. If we switch to top view, we can see that the origin is at the center of the X and Y location axis. That's exactly what we want, and that's why X and Y location values are set to 0. Next, we will add a mirror modifier the same way we did for the head. I will switch to edit mode, add loop cut, and delete the right side. Then I will add mirror modifier and enable clipping. We also need to add the subdivision modifier. And just like before, we will add few loop cuts to give torso more geometry and shape. While we're adding loop cut, using Ctrl R, you can use mouse scroll wheel to increase or decrease number of loop cuts. I want to scale side faces along the y-axis to give shape more rounded look. You can press slash key to enter local view. It hides everything else and lets you just focus on the selected object. Press it again to go back. Here, Blender is telling you that you are in local view. Okay, next we will model the forearm. I will switch to object mode. Remember, when we add a new object, it appears where the 3D cursor is. To move 3D cursor, hold Shift and press right mouse button where you want it. Then add another cube with Shift A. Let's name the new cube forearm and go to edit mode to shape it. I enable X-ray for transparency using Alt-Z. Then press A to select all. Use S to scale and R to rotate. For the forearm, I will not use side reference image because it has bad angle and makes things harder. And I will not move vertices individually because I want front and side edges to be same length. Scaling that face won't change length difference. If I want to change that angle, I will select all and then rotate because I want top and bottom faces to stay parallel. If we add mirror modifier, you can see things don't work as expected because by default the mirror modifier uses the origin point as the symmetry center. We can fix this by choosing mirror object, which uses its origin as the center for the mirroring. Again, we need subdivision modifier. We need loop cut here because of this curvy shape. If I press G twice, you see the edge loop that follows the yellow line. If I want to slide that direction, it won't let me. But I can press C to toggle clamp off. The guide extends and I can slide in that direction. This side sliding edge loop won't help much. But we have two other options to follow the referencing. First, we can add another loop cut and then slide it. Or we can increase for selected edges. Increasing edge crease makes the subdivided shape follow the original shape more closely. These purple edges indicate that Edge Crease is applied. You can find Edge Crease under Edge menu, or you can press Shift E to use the shortcut. You can press Ctrl E to open the Edge menu. Under the Subdivision Modifier settings, we can increase viewport level to add more geometry and make the model look smoother. Be careful not to increase it too much. It adds geometry quickly and can slow down or even crash your system. Okay, we continue with modeling the leg. First, I will switch to object mode. Move the cursor using Shift and right click, and then add the cube with Shift A. Let's give the new cube name. Switch to edit mode to edit it. I will toggle X-ray with Alt Z. Scale cube with S. I am adding mirror modifier. Mirror object will be torso again. We also need subdivision modifier. Here I will use Shift E for Edge Crease. Then we will do same steps. Switch to object mode, move cursor, adding new cube. I'll name it foot. I'll switch to edit mode, toggle on X-ray, scale the cube, and then add mirror and subdivision modifier. We also need mirror object to be torso, and let's choose viewport level 2. To get a shape similar to this, we need to extrude the top face. To understand what extrude does in Blender, I think it's better if you see it visually, and temporarily we disable the subdivision modifier. To extrude a face, we first need to select it and then press E. If we enable this subdivision modifier, you can see how it rounds and smooths the shape. I think we will get better result if we scale that face. You can see that these two edge loops are close each other. That's another way to create sharp edge if we don't use crease. I think the reference image from the left side is a bit unrealistic because this rounded shape is inside the lower leg. That's because it was generated with AI, so I won't stick to it completely. Remember, if you want to select a face while X-ray is on, you need to aim at the little black dot in the center of that face. I want to increase the crease for those edges to create sharper edges. The foot is done for now. This time I will add UV spear for the shoulder. Whenever you perform an operation in Blender, like adding an object, extruding or beveling, a small panel appears at the bottom left of the 3D viewport. This is the Adjust Last Operation panel, and it lets you tweak the settings of that operation immediately. Remember, it disappears once you do something else, so adjust it right away. For this UV sphere, we need to change the radius first. Remember, if you hold Shift while dragging with the mouse, the value changes more slowly, allowing more precise adjustment. Then we can reduce segments or rings, and even we can adjust its location. And we need mirror modifier. Next we will model the upper arm, and for that we will use cylinder. Again, I will tweak some parameters in Adjust Last Operation panel. And I'm also changing the rotation on the y-axis just to position the arm correctly. Now I think it's good time to talk about transform orientations. This time we will focus only on global and local orientations. Until now, we only use the global transform orientation. The global axis we saw earlier always follow the world, the fixed X, Y, and Z directions of the whole scene, and they never change. I'm temporarily enabling gizmos. You can see they match the global axis because global is active in the transform orientation. But if I switch to local, you can see the axis rotating with the object. Choosing global or local orientation system means you are telling the Blender which axis you want to follow. If I press G and then Z, object follows the local Z axis. But if I switch to global, object follows the global Z axis. You can switch between local and global transform orientation by pressing Z a second time. Watch how the local orientation rotates when we rotate the object. That's because the local orientation always follows the object's orientation, not the global axis. Here I'm using local X and Z axis to move object. Let's name this object upper arm and add here modifier. We also add some loop cuts to create even faces. We continue modeling the lead robot, and now we add the cylinder for the neck. We will use this panel again. Let's add some loop cuts as well. If we check next position, we see it's not exactly 0. We can see it here too. That's because I manually placed the 3D cursor when we created the cylinder. We can simply type 0 to fix this, and then name it neck. Okay, next we will model the ears, and we will use UV sphere for that. I will rotate it 90 degrees on the y-axis, because this way the edge loops match the ear shape better. We don't need the right half of the UV sphere, so I will delete it using X key. Now it's good time to try proportional editing. If I move the single vertex, only it moves. But with proportional editing on, everything inside the circle moves along with it. The closer a vertex is to this vertex, the more it follows. To turn proportional editing on or off, you can click this button, or just press the O key. I will turn off the move gizmo. And I will add an edge loop here. Remember, to select an edge loop, hold Alt and click an edge. In general, if you want to add any selection, hold Shift while selecting extra elements. Again, I will add Subdivision Modifier. Holding Alt to select edge loop. Using Shift E to increase Edge Crease. And we will name this one here. And this one will be shoulder. For upper leg, we will add another UV sphere. Segments will be 16, rings 9. Here I'm trying to match this edge loop to leg because I want to extrude it later. Remember, you can select everything using a key. Another useful selection method is to hold Ctrl, right mouse button, and draw selection area. Everything inside this area will be selected. Then you can press X to delete vertices. Here I am holding Alt to select edge loop, E to extrude, R to rotate. Then we will add loop cut with Ctrl R. Remember, you can scroll the mouse wheel to increase or decrease number of cuts. If we look from left side, it's visible that we need to adjust flex position. We can select this edge loop and with proportional editing enabled, we can curve leg a little bit. Neck also need adjusting. And the ears. Next we will create antenna. Another UV sphere for it. Don't forget to turn off proportional editing like I did. If we delete this vertex, all the faces that contain it will also be deleted. Then we select this edge loop and extrude along the z-axis. Then we rotate it from the left-hand front views. And move it. I will hide the reference images to see better and add mirror modifier. As you can see, I forgot to add the mirror modifier for the upper leg. But it's good because we will learn how to copy modifiers from one object to another. In object mode, you can add or remove objects from your selection by holding Shift and click on them. However, only the last selected object has a light orange color. We call this the active object. That's important to know because many operations in Blender depend on it. For example, in the Properties panel, you will see settings of the active object. If I select shoulder, you can see it has a mirror modifier. But if I select upper leg, it does not. If I hold Shift now and select shoulder, it will be active. And that's what we want. Because to copy modifiers from one object to another, source object must be active. It's clear that the copy modifiers is an operation between objects. So intuitively you should look for it in the object menu. It's under Link Transfer Data submenu. Or you can press Ctrl L to open it quickly. Now if I select the upper leg, you see it has received a copy of the mirror modifier from the shoulder with all the same settings. Let's rename it. And we will do same for antenna. Next we will model the hands. Since this is a beginner tutorial, we will use a very simple and easy to create shape, and we won't be using a reference image. This time we will add a single vertex. This creates a new object containing only one vertex. When we created it, Blender automatically switched it to edit mode. And this vertex is selected, so I can extrude it now with E key. When extruding, you can press Z to constrain movement to the Z-axis. I will extrude again, and this time I will press Shift Z. This lets you move freely along X and Y while keeping Z locked. I want to create 3 fingers, so I will repeat this extrusion 2 more times. First, I will select this vertex. If we look from front view, these vertices are on the same Z level, because we moved them with Shift Z. I want the fingers to have equal spacing, so I will switch to top view and roughly adjust the vertices. To select these 3 vertices, I will press A to select all, then hold Shift to deselect the middle one. If multiple vertices are selected, we can extrude them together. Now we will add Skin Modifier. It adds thickness to the vertices, turning them into a 3D shape. With Skin Modifier, if we press Ctrl A, we change the thickness of the selected vertices. So I will select all with A, then press Ctrl A to change radius for every vertex. We will add Subdivision Modifier to make geometry smooth and round. And we will increase subdivision level. The hand looks too big, so we need to scale it down. I'm switching front view to see proportions better. It's better to rotate in object mode to keep the mesh and its local transform orientation aligned. For example, we can use local z-axis when rotating if we press Z twice. Local Z works this way because we rotated the mesh in the object mode, which means the object local axes are rotated along with the mesh. Press A twice to deselect everything. Then select these vertices and scale them to move closer together. I will also move them along the local z-axis. In object mode, set the Y location to 0 to center the hand. Add mirror modifier and name it hand. To make an object look smoother without adding geometry, we can use a shade smooth. Flat shading gives one color per face, but shade smooth blends it with gradient, so model looks smooth. To enable it, select an object, right-click and choose shade smooth. To disable, select shade flat instead. If I enable shade smooth on the ears, you can see it smooth areas which we want to stay sharp. That's when Shade Auto Smooth comes handy. It adds a modifier and only smooth faces whose angle is less than the set limit, while edges with a large angle remain sharp. I'm selecting all objects using box select and left clicking while holding shift to deselect ears, and I will enable shade smooth for them. You can see it does not work on the hands, because the mesh was generated with the Skin Modifier. To fix this, just enable smooth shading in the Skin Modifier settings. Smooth shading smooths the shading between faces without adding any geometry. Looking at the head's silhouette, it still looks a bit blocky. To fix this, we can add geometry by increasing the subdivision level. Next we will model the screen, and for that we need to use part of the head's mesh. But before that, I think we should talk more about modifiers. I will switch to flat shading to see geometry better. For the head we are using mirror and subdivision modifier. If I disable them, you will see the actual geometry we have. Even in the outliner, you can see the mesh and its modifiers are listed separately. The green rectangle icon shows this is a mesh data. Object acts as a container for all of this. To understand how modifiers work, think of them as a function or tool. They take a mesh as an input and output a modified mesh. For first modifier, input mesh is the actual geometry we have. And to see what it returns, we can enable it. For second modifier, this is an input, and to see what it returns, we can enable it as well. In edit mode, we are editing the actual geometry, but the final result is still visible. If you want to work more like the final result, you can enable the on-cage button, which kind of does that. For example, with the subdivision modifier, you are still not editing all the final vertices, but this time you are not going to use it anyway. While we talk about modifiers, we should say that the order of modifiers also defines the final result. In our case, if I switch the subdivision modifier to be first, you can see we get different results. That's because the subdivision modifier first rounds the actual shape differently, and then the mirror modifier copies it to the other side. To model the screen on the robot's head, we need to use the final result of the modifiers. That means applying the subdivision modifier. But if we only apply subdivision, it turns the smoothed geometry into real mesh, and then the mirror modifier duplicates it. This gives us the same result as when we changed the order before. To solve this problem, we need to apply the mirror modifier as well. To apply a modifier, you can use this drop-down menu, but you can see it's disabled. That's because some modifiers can only be applied in the objects mode. That's just how Blender is designed. And remember, you should always apply modifiers in order from the first to the last. If I switch to edit mode, you can see the actual mesh looks different now. I will unhide reference images to model the screen and enable X-ray so we can see them. Let's add the mirror modifier again. First we will delete the right side. Then add the mirror modifier back to restore symmetry. With the X-ray enabled, we can see and select vertices from the back. But we only want to work on the front. So this is good time to learn how to hide and unhide the mesh. Hiding part of the mesh is really easy. Just select the part you don't want to see and press H to hide it. To show everything again, press Alt H. We want to create space for a screen by extruding inward, but the area does not have the edge loops that match the screen shape. To fix the edge flow, we will use the knife tool to cut edges exactly where we need them. To start using knife tool, press K. With the left click, we can draw the edge flow where we want to cut. At the end, press Enter to confirm. When you use the knife tool, grab or any tool, the status bar at the bottom shows shortcut hints. So if you forget what key confirms a cut or how to slide vertices, you can always check there. It's also a great way to learn new options. For example, if I press K for the knife tool and I forget how to confirm or cancel the operation, I can see the shortcuts in the status bar. Here our goal is to make the faces a similar size as possible. Remember, we press G twice to slide the vertex. The reason we slide is to try to keep the same shape. When we work on 3D mesh, it's very useful to have only quad faces. By quad face, I mean face with 4 vertices and 4 edges. Until we used the knife tool, we had only quads, but using the knife created triangles and bed poles. A triangle is a face with 3 vertices and 3 edges. A bed pole is a vertex where more than 5 edges meet, which can cause shading problems and make the mesh harder to work with. Topology is how faces, edges and vertices of the mesh are arranged. Good topology means edges follow the shape of the model, the faces are mostly quads, and the mesh deforms well when animated. In this tutorial we will not worry too much about good topology, because this is a beginner tutorial and main goal is to learn new tools and techniques, and same time keep it simple. Later on, when you get into more advanced modeling or animation, clean topology becomes more important. But for now, let's just focus on learning and having fun. We will add Subdivision Modifier again because we need smaller faces for the screen. And it will also turn the mesh into quads, even if we had triangles before. But keep in mind, these quads are created by splitting, not by fixing topology. I forgot to enable clipping, so I will do it now. Here I'm holding Ctrl and right click to select these faces. Before extruding these faces inward, we will duplicate them for the screen glass using Shift D. And to drop them in place, just press Escape or right click. To separate a selected mesh as a new object, we can press P and then choose Selection. After separating, we stay in edit mode of the old object, and both objects are selected. I will name the new object Screen Glass. Now I am in local view. To hide the glass, I press slash twice. To go out and back in, so the glass won't be in local view. I will select these vertices again and extrude them inward with E. To select this edge loop, I'm holding Alt. And here I'm holding Shift as well to add selection. Then we will increase the crease for sharper edges with Shift E. This edge loop we want to make better rounded. To do that, we can use bevel. Press Ctrl B to bevel. Move the mouse to adjust the width. Use the mouse wheel to change the number of segments. And left click to confirm. While using Bevel, you can see all other options in status bar. Merging vertices is useful to clean up your mesh, removing unnecessary points and make edges connect properly. For example, we can select these vertices, press M, and choose at center to merge them. Now I will switch to Object Mode and enable Shade Auto Smooth. But the shading on these faces are still sharp. That's because the angle between neighboring faces is greater than 30 degrees. We can fix this by simply increasing the angle. To separate the screen into new object, we need to select its faces. We will use the Circle Select tool so we can learn a new selection method. First, I will switch to Face Selection mode. And to activate the Circle Select tool, I press C. This circle you see works like a brush, and you can draw over the mesh to add selection. With the mouse wheel, you can increase or decrease the brush size. To deselect, hold Shift while drawing, or use the middle mouse button. To confirm, press Enter or right-click. To separate, press P and choose Selection. Then name the new object Screen. Next, we will slightly shape the screen glass. To exit local view, I press slash and hide the reference images since we no longer need them. Now we are in edit mode for the head object, and this icon indicates it. Clicking the white dot next to the screen glass, let us quickly switch the active editable object. If you hold Ctrl while clicking the white dot, you can edit multiple objects at the same time. I'm switching to Edge Selection mode because I want to select an edge loop, and to do that we hold Alt while clicking an edge. Press E to extrude, then Y to move it along the Y axis. I'm holding Shift for finer control. Now I want to scale along the Z axis to fill this gap, so I press S, then Z. To select all, press A, G for grab, and Y to constrain movement. Let's enable Shade Smooth on the glass and increase subdivision level for both glass and head. The arms and legs also look a bit blocky. We'll also fix the foot position. Now that we finished modeling, let's talk about materials. Materials gives object their look, like color, shyness, roughness, or whether they look like metal, plastic, or transparent glass. They also define how the surface reacts to light. In the top right corner of the 3D viewport, we can choose how objects are displayed. So far we only used solid and wireframe modes. To create and see materials, we need to switch to Material Preview mode. This mode shows the objects with its materials and basic lighting, so we can preview how it will look without rendering. In the Materials tab, we can see which materials are assigned to the selected object, change them or add new ones. From this drop-down menu, we can pick an existing material or create a new one with this button. When we create a new material, Blender automatically names it material with a number, as you can see here, but we will rename it to robot metal. In the surface panel, we see Principal BSDF. That's just Blender's main material type, and it's good because we can make almost anything with it, metal, plastic, or glass. Here we will focus on three parameters: base color, metallic, and roughness. Base color sets the material's color. For our robot, I will set it to a bright yellow paint. I'm copying this exact color value. You can copy it from here or pick something you like. Metallic controls if the surface looks like metal. I will leave it at 0 so it looks like paint, not metal. Roughness controls how shiny the surface is. Higher values make it matte. Lower values make it reflective. I will set it 0.2 so it looks like glossy and shiny, like fresh paint. I will rename this material to make it more precise. We can use this material on multiple objects. If I select head, I can pick the same material from here. We can copy the material from the active object to multiple objects with a single command. Hold Shift to select multiple objects. Then select the one whose material you want to copy. The last selected becomes the active object. Press Ctrl L and choose Link Materials. This way we created one material and linked it to the multiple objects. If you want an independent copy or slightly different material, click this button to duplicate it and then modify it however you like. We will make the resin material from it. Again, I am copying the predefined values, so you can do the same. I will link this material to other parts as well. Before we create screen glass material, I want to talk about rendering engines. We can choose the engine from the Properties Render tab. Rendering is the process of creating the final image from your 3D scene. In Blender, we have two main engines, Eevee and Cycles. Eevee is real-time and very fast. It's a great for quick previews or projects where speed matters more than accuracy. Cycles is more powerful and physically accurate. It simulates real light, so it's perfect for effects like glass and reflections, but it takes longer to render. I will use Cycles for our glass material, because it's easy to make object transparent and the final render looks better. This also gives me a chance to show how cycle looks. The settings below are specific to the render you choose, so this will change if you switch to Eevee. To see how our scene looks like in cycles, we switch to rendered mode. This mode shows us live preview of all lighting, shadows, and true material effects like transparency. You can also press Z to open viewport shading menu and switch modes quickly. If we look this drop-down menu for rendered mode, we can see that under lighting, scene world is checked. That means Blender is using lighting defined in the Properties World tab, which can make the result look different from Material Preview. For now, I will disable it, because we don't have any lights in this scene yet, and I want to create a lighting similar to what we see in Material Preview mode, to make it easier to compare. When we disable scene world lighting, Blender uses HDRI selected here. Think of HDRI and lighting from the World tab like a giant sphere surrounding the scene that shines light into everything. I will set the device to the GPU compute, so Blender can use the graphics card to render faster. And I will enable the noise to reduce noise in the render and get a cleaner image in the 3D viewport. Now we will create the screen glass material. Select the object, go to the Material tab, click New, and name it Screen Glass. First, set the transmission weight to 0.9. This controls how much light can pass through the material. So at 0.9, most of the light goes through, and it acts like glass. Next, change the IOR. This defines how much light bends when passing through the material. Since it's very close to 1, the glass acts almost like air and stays clear without much distortion. Finally, set the roughness to 0.1. Lower values make the glass shiny, while higher values scatter light and make it look blurry. I see some extra space around the screen, so I want to fix it by scaling, but first I need to select the screen. When I try to click it, Blender selects the glass in front instead. In cases like this, you can either click multiple times in the same spot to cycle through objects, or hold Alt while left-clicking to pick the object from the menu. Now I want to scale it, but I will do it in Object mode, not in Edit mode. If you look at the scale values right now, they are all set to 1. When I scale the object, you can see those numbers change. This is something beginners often miss. They resize an object but never apply the scale. That can cause problems later with modifiers, physics, or shading. To avoid that, you can either scale in Edit mode or apply the scale in Object mode with Ctrl A and choose Scale. That resets the values back to 1 while keeping the object size. A single object can have multiple materials, and that's exactly what we need for the screen. That's what we will learn next. Here I'm holding Ctrl to select multiple objects in Outliner. Then pressing slash to switch local view and hide everything else. Holding Z to switch wireframe mode. Then clicking on the screen to make it active, and in Subdivision Modifier settings, I will disable optimal display. Remember, you can enable X-ray with Alt-Z. Our plan is to make two materials, one for when the screen is on and one for when it's off. We will use both of these on the screen object to draw the face. To do that, we will assign one material to one group of faces and the other material to the rest. I'm increasing the subdivision level so the faces are smaller, which makes it easier to draw a more detailed face. Remember, we need to apply the modifiers first before we can assign materials to the faces they create. To apply all modifiers at once, we can right-click on the object and choose Convert to Mesh. In the Edit mode, we can subdivide the selected geometry by right-clicking and choosing Subdivide. We will use the Mirror modifier again to speed up modeling. Next, we will create material and name it Screen Off. Let's try Pure Black with roughness 0.8. In Blender, a material slot lets you assign material to part of an object. Think of a slot as a group of faces. You assign faces to the slot, then assign a material to it, and all those faces will use that material. When you create material, Blender automatically creates one material slot, and all faces of that object are assigned to it. To make it easier to understand, let's add another slot. Slots themselves don't have names. Blender shows the material assigned to each slot on the right. Right now we have two slots. The first has a material assigned and second does not. If I select the first slot, you will see its parameter settings below. That's because Blender always shows the parameters for the active slot. Now I'm selecting the second slot. And you can see it does not have any material. So we create one and name it Screen On. Screen On is white, but we don't see it on the screen object yet because no faces are assigned to that slot. To show this, I will select some random faces on the screen object and click the Assign button to assign them to the active slot. There are three buttons for managing slots. The Assign button assigns active material to selected faces. The Select button selects all faces in the active slot. And Deselect removes the selection from the active slot. Before I click it, I will select all to make it more visible. Now I want to completely remove the screen on material from the object. I'm selecting all, then selecting Screen Off and clicking Assign button. Press Alt-A to deselect everything. Press Shift-Z to toggle wireframe mode on and off. And enable X-ray if it's not already enabled with Alt-Z. Next, switch to face selection mode. And press C to activate Circle Select tool. Then select the faces where you want to apply the screen on material. After selecting the faces, switch to Material Preview mode. Then select the Screen on Material slot and click Assign. Now I will exit to Local View, hide the reference objects again, then switch to Object mode and Rendered mode. We already made Screen on Material using the principal BSDF shader. Since it's a screen, I will switch it to Emission shader. The emission shader makes the material actually emit light, so it looks like the screen is glowing a little. This is also a good way to show you what a shader is. Each shader controls how the surface interacts with light. When you select a shader, its options appears below. Here I will increase the strength. Next, we will add a background and light to render the final image. Use Shift-C to place 3D cursor in the center of the scene. Unhide the environment collection and select it. Because any new object automatically goes to the selected collection. For the background, we will use Plane. If you press F12 or go to Render menu and click Render Image, it will start rendering the image using the active camera view in the scene. We see the cube in the render image, but not in the viewport. That's because we hid it from the viewport only. We can hide it from the render using this icon. If I render again, we don't see it. Now we know the render comes from the active camera. To change the angle of the final image, we just move or rotate the camera. To switch the camera view, you can click this icon. Or hold the tilde key and choose View Camera, like we did before. Now that we are in camera view, you see this lock icon. When it's enabled, you can move, rotate or zoom the viewport just like normal, and the camera will follow. So you are adjusting the camera while seeing exactly what it will render. If it's disabled, moving the viewport won't affect the camera's position. We can resize the background object so it fully covers what the camera sees. I switch to Edit mode and scale along the x-axis. And then y-axis too. Press Shift-C to toggle wireframe mode. Go to Edge mode. Select this edge and extrude along the z-axis. Then select this edge again and bevel it with Ctrl B. Use the mouse wheel to increase segments. Confirm the bevel, switch to Object mode, then press Shift-Z to return rendered view. Remember, we are using HDRI lighting selected here. If we check Scene World, then Blender will use World Lighting defined here. Now I will select the light from the outliner. Press Shift-T to duplicate it. Then press X to move it along the x-axis. In the Data tab, you can change color and power of selected light. In solid view, those edges look sharp because we have not applied smooth shading yet. Let's do it now and name this object as well. I want to add some cubes so scene is not empty. We will use snapping to easily place the cube on the ground. We can activate snapping from here, or hold Ctrl when we need it. Before we use it, we need to set its options here. Snap Base tells Blender which part of the object should align to the target. Here we want the cube's bottom to snap to the ground, so we set it to closest, because the bottom is the closest part to the ground. Snap Target tells Blender which part of the other object your object will stick to when snapping. Here we are targeting the ground's face, so we set it to face. First grab the cube, then hold Ctrl and move mouse over the ground to snap it. Left click to confirm. If snapping is enabled, you don't need to hold Ctrl. To duplicate, use Shift D, and then with Shift Z, we are telling Blender not to move the cube on the Z axis. In other words, we want to move the cube only on the X and Y axis. If I scale the cube, it scales from the origin point. In this case, the origin and the pivot point are the same. But if I set the pivot point to the 3D cursor, then the pivot point is different from the origin. The pivot point is simply the center that Blender uses for the scaling and rotation. There are different pivot point modes, like using the origin, the 3D cursor, or median point. We won't cover all of them here. In object mode, the median point means Blender will scale or rotate the object around its origin. But here we want to scale the cube so it stays on the ground. To solve this problem, we have to move the origin to the bottom face. If you right-click and choose Set Origin, you have several options. For example, if I choose Origin to Geometry, it moves the origin to the center of the object. To move the cursor to the center of the bottom face, go to Edit Mode, switch to Face Select Mode, enable X-ray, and select the bottom face. Then press Shift S to open the snap menu and snap the cursor to the selection. After moving the cursor, go to Object Mode, right-click to the object, and choose Set Origin, Origin to 3D Cursor. Now when we scale, the cube stays on the ground. Let's duplicate it a few times and scale along the Z-axis. Next, we enabled camera's depth of field to keep the robot in focus and blur the background. First, select the camera and enable depth of field. Then, set the focus object to head. Finally, adjust the f-stop to control the strength of the blur. I want to change the camera angle a little. And you can adjust it however you like. I'm also moving the antenna up a bit to give some height. Press F12 to render the image. Blender uses samples to calculate the lighting, so at first it looks noisy but it gets smoother as more samples finish. Here you can see the current count, and once it reaches the final number, the render is done. And with that, this tutorial is over. Congratulations on making it to the end. If you learned something, feel free to like the video and subscribe for more. And if you have any question, just leave them in the comments. I will be happy to answer, as long as the video is not too old. Thanks so much for watching and enjoy your new creation.